Hello everyone, welcome to this fourth video on complex integration. This video will help you to give you an idea how to apply the Cauchy formula for derivatives to any given problem. So we are going to see Cauchy integral formula for derivatives in this video. So the problem goes like evaluate the integral over c is it e power 2z by z minus 1 the whole cube dz, where c is going to be the circle mod z plus I equal to 2. The first thing is we need to see that we have z minus 1 the whole cube to be there in the denominator. Point number 1, to get the poles, what we have to do? We will have to equate the denominator to 0. When I equate the denominator to 0, I have z minus 1 the whole cube is equal to 0. So I have z is equal to 1 to be a pole, but is it one time repeated? No, it is repeated 1, 1, 1 3 times. So z equal to 1 is a pole of what is going to be the order? Order is going to be 3. So you consider this to be a multiple pole. What we have been given is a multiple pole. The pole is got by equating denominator to 0. Z minus 1 the whole cube is 0. So z is equal to 1 3 times. So it is a pole of order 3. So point number 1 is over. What is going to be point number 2? Point number 2 is I'll have to plot the pole. So I need the boundary for the plotting. What is going to be the boundary? Z plus I equal to 2. So I have x plus iy, which is going to be my z, plus I to be equal to 2. So now combine the real part. So this is my real part. Combine your imaginary part. So what will happen? I times of y plus 1 equal to 2. Now this gives me what is to be done to the modulus? X square plus y plus 1 the whole square root equal to 2. Now I can remove the square root by squaring on both sides. So I have x square plus y plus 1 the whole square equal to 2 square. Rewrite this as the form x minus 0 the whole square plus y plus 1 the whole square equal to 2 square. Now identifying this one with the general formula, x minus a the whole square, y minus b the whole square equal to your r square, with circle having center a comma b and radius equal to r units. So in which case, what is going to be the circle's center? It is going to be 0 comma minus 1. And what is going to be the radius? Radius is equal to 2 units. So where will be having the point 0 comma minus 1 in the plane? Considering this as my x-axis and this is going to be my y-axis, this is going to be the point 0, 1, 2, 3. This is going to be minus 1, minus 2, minus 3. This is going to be 1, 2, 3. This is going to be minus 1, minus 2, minus 3 and so on. What is going to be the center? What we see as the center is 0 comma minus 1. Where is going to be 0 comma minus 1? We have 0 comma minus 1 is going to be 0 and minus 1. So this is my point 0 comma minus 1. What is going to be the radius? Radius is 2 units. So what I need to do? Move 2 units over here in all direction. 1, 2. So this is going to be 2 units. 1, 2. This is going to be 2 units. 1, 2. This is going to be 2 units. And this is going to be minus 1, minus 2, 2 units. So with minus 2 comma 0, 2 comma 0, 0 comma 3 and 0 comma 1, we are going to draw the circle. So we are going to have the circle with center to be equal to minus 1 comma 0, that is going to cover all this 4 points as boundary. So this is going to be my circle. Let us see it in the plane. So what we have is this is going to be my center, minus 1 comma 0 and passing through 1. This is going to be the quantity and minus 3 in the denominator. like what we have plotted. What is going to be the third point? What we have? We have the poles. What is going to be my pole? Z is equal to 1 is going to be my pole. So I have my pole to be equal to Z equal to 1. So this can be written as 1 plus I0. So what is the coordinate x comma y? X comma y is 1 comma 0. My next point is to see whether this pole lies inside or outside the given boundary. Where is the point 1 comma 0? Now we will search for the point 1 comma 0. 1 comma 0 lies over here. So is it lying inside or outside? Yes, it is lying inside. So we will be able to evaluate the integral. The pole is lying inside the circle, given circle. So you can evaluate the integral over C, the function f of z by z minus a into dz for. But now look into the denominator. Is it going to be a simple pole? No, it is going to be a pole of order 3. So I need to apply the Cauchy formula for derivative to solve this problem. So we will have to recollect the Cauchy formula for derivative. Recollect it as integral over C f of z by z minus a power n plus 1 dz is 2 pi I by n factorial f n of a. What is the question we have? Integral over C. We have this to be equal to the numerator z e power 2z, z e power 2z divided by what is there in the denominator, z minus 1 the whole cube. So this is z minus 1 the whole cube dz. Now compare it. What is in place of f of z? In place of f of z I have z e power 2z. Now what is in place of z minus a? In place of z minus a, I have z minus 1. So what is my a? My a is going to be equal to 1. Now what is in place of n plus 1? In place of n plus 1, I have it to be equal to 3. So what will be n? It is 3 minus 1. So n is going to be equal to 2 for me. Now I am ready. So what is the right hand side? It is 2 pi I divided by n factorial. So it is 2 factorial into f n of a. So n is 2. So it is double derivative of a. 2 factorial is 2. So this 2 can be cancelled off. So I have pi I into f double dash of a. So what is this f double dash of a? It is going to be f double dash of 1. So before moving on to this, I need to get the derivative. So we will find the derivative. What is our f of z? It is z e power 2z. The first derivative. So this is going to be in product. Let me keep, so differentiation of uv is u dv plus v du. Keep your z as such. E power 2z on differentiation is e power 2z into 2. Plus keep your e power 2z as such, z on differentiation is going to be 1. This is my first order derivative. Let me move on to the second order derivative. F double dash of z is going to be equal to 2 is a constant. Keep your z as such. E power 2z on differentiation is e power 2z into 2, and keeping e power 2z as such, z on differentiation is going to be equal to 1. Now outside there is going to be e power 2z, which on differentiation gives you e power 2z into 2. Now this is my second derivative. I want the value of the second derivative at the point 1. So what will be f double dash of 1? Wherever I have z, replace your z with 1. So this becomes 2, z becomes 1, e power 2 into z becomes 2 e to the power of 2 plus z takes the value 1, e to the power of 2 plus 2 e to the power of 2. So 2 e power 2 plus e power 2 makes it 3 e power 2. 3 2s are 6 e power 2. 6 plus 2 makes it as 8 e power 2. So this becomes 8 e to the power of 2, which is the value of my f double dash of 1. This has to be multiplied with what? Pi I. So what is going to be the final answer? The evaluation of integral over C z e power 2z by z minus 1 the whole cube gets the value as pi I into 8 e to the power of 2. We will try solving one more problem using the evaluation of integral over C 1 by z plus 1 into z cube dz, where C is going to be the circle mod z is equal to 2. So the first point is to find your poles. How to get your poles or the singularity? Equate the denominator to 0. So z plus 4 into z cube is equal to 0. Z plus 4 equal to 0 gives you z is equal to minus 4. And z cube equal to 0 gives you z is equal to 0. How many times? This is going to be 3 times. In which case z equal to minus 4 is going to be a simple pole, but this point with z equal to 0 is going to be a multiple pole. And what is going to be the order of the pole? Order is going to be equal to 3. So the first point, pole, has been got. What is the second point? Second point is drawing the boundary. What is going to be the boundary? Mod z is equal to 2. What does mod z is equal to 2 represent? Mod z is equal to 2 is going to be x plus iy equal to 2, x square plus y square, the whole square equal to 2. So x square plus y square equal to 2 square. This represents a circle with center to be equal to 0, 0 and radius is equal to 2 units. So let us now try plotting this circle over here. Now this gives you the circle with center 0, 0 and radius to be equal to 2 units as required. Now what is the next point? We need to we'll have to see the identify the position of the poles. Z equal to minus 4, Z is equal to 0. So what happens over here? We have two poles, Z equal to minus 4 and Z is equal to 0. This minus 4, I can write it as minus 4 plus I0. So this gives the point x comma y as minus 4 comma 0. And this I can write it as 0 plus I0. So what is going to be my point x comma y? It becomes 0 comma 0. Now the pole which is going to be minus 4 plus I0. Where do you find this minus 4? This minus 4 comma 0 is going to be in this point. So what do you think is going to be this point? Is it lying inside our boundary? No, this point is not lying inside our boundary. It lies outside. What is going to be the next point which we have? The point is 0 comma 0, which is going to be 0 comma 0. This is going to be the center 0 comma 0. Does it lie inside the boundary? Yes, this lies inside the boundary. So we see that out of the 2 points, one of them lie outside and the other point lie inside. As we have already discussed, if there are going to be points that lie outside, the outside point can be clubbed with your f of z for simplification's sake, leaving the point below the inside quantity alone. Hence, what will happen over here is this z plus 4 that lies outside can be taken to your numerator, leaving this z cube alone in the denominator. In which case, I can write integral over C. What happens is 1 divided by z plus 4 goes to the numerator, leaving you with z cube alone in my denominator. Hence, you can identify this with f of z by z minus a the whole to the power of n plus 1 dz. Now tell me what is in place of f of z. In place of f of z, we have this to be equal to 1 divided by z plus 4. Now in place of z minus a, what do I have? I have it to be z minus 0. Z minus a equal to z. So what is in place of a? It is 0. So a equal to 0. What is the next thing which we need? In place of n plus 1. What do we have in place of n plus 1? In place of n plus 1, I have this to be equal to 3. So n is going to be equal to 3 minus 1. So n is going to be equal to 2. Now the formula for this happens to be equal to, go check out for the formula for your derivative. The formula for derivative says 2 pi I by n factorial f n of a. Copy paste it over here. 2 pi I divided by n factorial into fn of a. So this is going to be equal to 2 pi I divided by 2 factorial into f double derivative of a. So this is going to be my value of the integral over C, 1 by z plus 4 the divided by z cube dz. Now we are ready for the final task. 2 factorial and 2 can be cancelled off. What I want is f double derivative of a. What is my f of z? I can rewrite this as z plus 4 the whole to the power of minus 1. Take it to the numerator. Get for the derivative, first derivative minus 1 into z plus 4 whole power minus 1 into minus 1, so that makes it minus 2. F double derivative of z makes it as minus 1 minus 2 z plus 4 whole power minus 3. So now this simplifies as 2 into 1 2 divided by z plus 4 whole to the power of positive 3. So this is my f double derivative of z. What is our requirement? I want the value at the point a equal to 0. So what is my a? F double derivative of 0. So that becomes 2 divided by 0 plus 4 the whole cube. So it is 2 divided by 4 cube makes it as 64. This goes how many times? 32 times. So the value now becomes f double derivative of a gets replaced as 1 divided by 32. Hence the value of the integration over here is pi I into 1 by 32. So that makes it as pi I divided by 32. Hence you can keep in mind when there are going to be multiple poles with one of the pole lying outside and one pole lying inside, keep the pole that lie inside in the denominator and take the pole that lies outside to your numerator and consider it as f of z. This will avoid the complexity of taking partial fraction and then solving the problem. Thank you.